Today's video is going to be on Chapter 2, your second quiz review. And we're going to start off our review by looking at how to write a linear equation from a diagram. So we want to figure out the pattern. First thing I want to do is count the blocks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we go from 5 to 8, 8 to 11. So what we're doing is we're adding 3 blocks each time. And you can see that the blocks are added on the outside of the t. That gives us the first part of our function rule. Since we're adding 3 blocks, that is our rate of change. So that is going to be our slope. So it's the number with our variable. So y is equal to 3x. And now what we want is we want our starting point. And what you've got to remember is that starting point is always going to be instance 0. Here's 1, 2, 3. To find 0, we have to work backwards. So if I'm going to add 3 each time, when I subtract 3 blocks to work backwards, I would be starting with 2 blocks. So our y-intercept, which is our starting point, is going to be 2. Therefore, our equation is y equals 3x plus 2. We want to find out the number of squares for instance 12. If I want instance 12, that's going to be our x. Y, in this case, is the number of blocks, the total number of blocks, and x is representing the instance number. So if we want instance 12, we've got y is equal to 3 times 12 plus 2, 36 plus 2. We would have a total of 38 blocks. That's writing an equation from a pattern from a diagram. Then we talked about writing equations in 3 different forms: slope-intercept form, standard form, and point-slope form. Our first one, we want to write the equation in slope-intercept form, given a point and the slope. If you go directly to slope-intercept form, we need the slope and the y-intercept. We look at our point. Our point is not the y-intercept because the x-coordinate is not 0. So what we're going to do is we're going to start in point-slope form. Y minus 6 is equal to a negative 3, x minus 4, and then we are going to distribute and solve. So we've got y minus 6 is equal to a negative 3x plus 12, and then to get y by itself, we add 6 to each side. Y is equal to a negative 3x plus 18. So don't forget your 3 forms. Slope-intercept form, y equals mx plus b. Point-slope form, y minus y1 equals m times x minus x1. And remember, you're replacing the x1, the y1, and the m. And then last, standard form, your x is first, your y is second, and it's set equal to your number. Where a and b and c, you can't have any fractions or decimals. So when we go to our next one, we want to write our next equation in standard form. We're given 2 points. We need to start by finding our slope. So we've got a negative 1 minus 2 over 1 minus negative 5, which is a positive 5, negative 3 over 6. So we start off with a slope of a negative 1/2. From this point, we've got 2 points and a slope. The only form that we can go into with 2 points and a slope is point-slope form. So that's where we're going to start. We're going to choose, I'm going to choose the first point. It doesn't matter which point you choose. So we've got y minus y1, so y minus 2 is equal to your slope of a negative 1/2, x minus a negative 5, which means it's plus 5. Distribute, and we've got a negative 1/2 x minus 5/2. Add 2 to each side, and we've got y is equal to a negative 1/2 x. Now if we look at this, this is really a negative 2.5. 5/2 is the same thing as 2.5. So if I add 2, I'm left with a negative 1/2. Now we've changed our equation from point-slope form. Now we are, from point-slope form to slope-intercept form. Now we need to change it from slope-intercept form to standard form. We've got to make that x in the right spot, so we've got to move that x so that comes first. That gives us, when we move to the other side, a positive 1/2 x plus y is equal to a negative 1/2. Now we need to get rid of the fractions. So I want to look at, I have two fractions in this case. We're lucky in the fact that both of the bottoms are the same. Both denominators are the same. So we're going to go ahead and multiply by 2. If they weren't the same, you're going to multiply with the least common multiple so you can get rid of both of them. And that gives us 2 times 1/2 is 1x plus 2y is equal to a negative 1. And this would be our equation finally in standard form. Next one, we want to write in point slope form given 2 points. So when we're given 2 points, the only thing that we're missing is our slope. 15 minus 8 over 10 minus 3 is equal to 7 over 7, giving us a slope of 1. I'm going to choose the first one. So we've got y minus y1, which is 8, equals your slope, which is 1, x minus x1, which is 3. And it's nice that unlike our last problem, we are now done. So how much work you need to do to write the equation really depends on which form that you need to write it in, and it depends on what information you're given to start with. Are you given the slope? Are you given the y-intercept? Are you given 2 points? Do you have to find the slope? Do you have to find the y-intercept? So you really kind of have to piece through the puzzle. Go ahead and press pause and see if you can do the next one on your own. When you're done, press play. Alright, that may have only taken you 2 seconds because if you looked at the original equation, you would have seen that both of your x-coordinates are a negative 8. As soon as you see that both x-coordinates are a negative 8, you can say that the equation of the line is x equals a negative 8. If you didn't see that and you went and you found your slope, did your y2 minus y1, x2 minus x1, you would have found that your slope is undefined, and then that should have led you to the fact that you had a vertical line, which would have led you back to your original 2 points. Alright, so now we're talking about parallel and perpendicular lines. So we want to write the equation of the line. We want it to be in slope-intercept form, so we know that our answer is going to be in y equals mx plus b form. We want our line to be perpendicular to y equals 3x minus 5. So our given slope in this case is 3, which means our new equation, we want to have a perpendicular slope, opposite reciprocal, so that's a negative 1/3, and going through the point 9, negative 12. So for our equation, we are using the slope of a negative 1/3, and we're using the point 9, negative 12. Since we want it to be in slope-intercept form, we look at the point and see if it's the y-intercept. Because the x is not 0, it's not in y-intercept, or it's not our y-intercept. So we have to start in point slope form. Y minus a negative 12, so y plus 12 is equal to our slope of a negative 1/3, parentheses x minus 9. Now distribute. So we've got y plus 12 is equal to a negative 1/3 x plus 3. Subtract 12 from each side, and we've got y is equal to a negative 1/3 x minus 9. So make sure that you've satisfied all parts of the problem, the slope, the form, everything. Alright, so now we are going to move on to our line of best fit, or our linear regression line. The price of gas is always increasing. Below is a table representing gas prices over the years. Let T represent the number of years since 1980. The most important statement here is that T is representing the number of years since 1980. So you can't go into your calculator and plug in 1985, 1990, 1995, 2000, 2005. You really have to be careful when they define the parameters for your variables. If it's the number of years since 1980, well, 1985 happened 5 years later, so our T is 5. This is 10 years after 1980. This is 15 years after 1980. 20 years later, 25 years later. So we're no longer going to be looking at the corresponding year. We're looking at our T value and our gas price per gallon. So make sure that on your quiz you're paying attention to see am I defining your x variable or your t variable, whatever your independent variable is, in a special way? If I am defining it in a special way, you have to adjust for that. So what we want to do is we want to find the best fitting line for the data. So this is where we pull out your calculator. Alright, to enter your data in, hit Stat. We want to edit our data, 1. I already have my data entered in, so press pause and go ahead and enter your data in. Once you're done, press play. Alright, so to find the best fitting line once you have your data in, we're going to go back to Stat. Instead of editing this time, we're going to arrow to the right under calculation, and we want number 4, lin reg. So we hit number 4. We want it to be L1, which is second 1, comma, which is above the 7, second 2, L2, because that's where we put our x's and our y's at. We hit enter, and we see that it's y equals ax plus b, which is very similar to our y equals mx plus b. We're given a and b, so we're just going to use that. Y equals 1.138 x plus 0.18. What does the slope represent? Well, 0.138 is representing your slope, and it's always your y per your x. So in this case, it's gas price per year. And technically per year since 1980, but it's your y per your x. Estimate how much a gallon will cost in 2020. Again, we're not going to plug in 2020. 2020 is 40 years after 1980. So we're going to plug in a corresponding value when t is 40. So y is equal to 0.138 times 40 plus 0.18. And when you calculate that, you get about $5.70. So in just a few years, it's estimated that our gas prices are going to be $5.70. Did you use interpolation or extrapolation? So our data ranged from 85 to 2005. 2020 happened outside of that data set. Remember, think about interior, exterior. Interior house is inside, exterior is outside. So interpolation would be inside of, so between 1985 and 2005. It didn't happen outside, so that's extrapolation. And our very last thing is graphing our inequalities. And remember, we're going to graph this just like a regular line. Our y-intercept at 2, our slope of a negative 7, which is a negative 7 over 1. So we're going down 7, right 1. Or I can go up 7 and left 1. Because I have a greater than or equal to, I'm going to have a solid line connecting those points together. Now, greater than or equal to, I've got to figure out which way am I going to shade my line. Am I going to shade it to the right or to the left? We could use a test point, but that 0, 0 is kind of iffy, so let's just go over to negative 2, 0. Our y is 0, greater than or equal to negative 7 times negative 2 plus 2. So that's 14 plus 2. 0 is greater than or equal to 16. That's not true. So that point's not going to be true, which means we are going to shade everything to the right of our line. Then we've got y is less than a negative 5. Y equals a number is a horizontal line. So I've got a horizontal line when y is negative 5. Since it's less than, we're going to have a dashed line. And since it's less than that, we are going to shade everything below. If you didn't know which way to shade, remember, use your test point. 0, 0 would be the easiest point for that one to test. And then last but not least, also make sure for your quiz tomorrow you look over your notes for direct variation. There will be direct variation questions on your quiz, and how to find the rate of change. How to find the rate of change from given points, from a graph, from a table, and remember, rate of change is just your slope. So make sure that you double check over those topics and are prepared for your quiz tomorrow. And you're all done for your notes for today.